Welcome in Dark Core. There are hundreds of billions of planets caught up in the vast whirlpool of the Milky Way galaxy. From Earth, a lonely outpost floating on one of its spiral arms, humans have begun to peer across the void, and just recently scientists have found the first Earth-sized habitable zone world. NASA's Exoplanet program was created to find unmistakable signs of life on other planets. During the search for extraterrestrial life on Earth-like planets, NASA has found some incredibly bizarre alien worlds. We'll talk briefly about the planet's host star and the discovered Earth-like planets themselves. PSR J1719-1438 is probably one of the most fantastical cosmic objects you'll learn about here. The first thing to know is that 1438 is a neutron star, a small but incredibly dense stellar object which usually averages no more than 12 miles in diameter. Neutron stars are so dense that just 1 teaspoon of their stellar material would weigh about 1 billion tons on Earth. It's also a pulsar, which is a neutron star that emits strong beams of electromagnetic radiation from its magnetic poles and has intense magnetic fields about 1 trillion times stronger than Earth's magnetic field. Some pulsars have an amazingly fast rotational spin, but 1438 is known as a millisecond pulsar that has a spin period of 5.4 milliseconds, that's about 10,000 rotations per minute. But we're talking about exoplanets here, and that's why the most impressive feature of the neutron star is a companion 1438b, which is about the same mass as Jupiter but is only about 40% the size of the gas giant. So what happened that made this planet so small and so massive? Scientists believe that 1438b is a remnant of a star that had its outer layers stripped away by the pulsar with its incredibly strong magnetic field. What's left is a planet that's composed largely of crystalline carbon, making this planet a giant diamond, 5 times larger than the Earth but with a density far greater than diamonds. Another incredibly mysterious planet is orbiting just 63 light-years away from Earth, named HD 189733b. First discovered in 2005, its blue color comes not from a reflection of an ocean like Earth, but instead from a hazy, blowtorched atmosphere containing clouds laced with silicate particles. This gas giant has daytime temperatures of 2,000 degrees Fahrenheit and 500-mile-per-hour winds. Under these conditions, it's speculated that it may rain liquid glass sideways. The planet is only 2.9 million miles away from its parent star, so close that it's gravitationally locked where one side always faces a star. By comparison, Mercury, the closest planet to the Sun in our solar system, is 29 million miles away. First discovered in 1999 and named after the transiting planets and Planetismo's small telescope used to find it, TRAPPIST-1 is an ultra-cool red dwarf star that is slightly larger but far more massive than the planet Jupiter. It's about 39.6 light-years away from the Sun. The very first planet that NASA found that had a radii similar to Earth was Kepler 186f in 2014. This discovery confirmed that Earth-sized planets do exist in the habitable zones of other stars and signaled a step closer to finding a world similar to our own. In 2015, astronomers used NASA's Spitzer Space Telescope along with ground-based telescopes and found not 1 but 7 temperate terrestrial planets that orbit the red dwarf. These very Earth-like alien worlds are mostly rocky and some have a potential of holding up to 250 times as much water as planet Earth. These 6 planets could lie in the optimistic habitable zone, and are so close together that if you were standing on the surface of one, you could see the other planets as moons. But the red dwarf star only puts out 0.5% of the energy of our Sun, and so the planets are dark and cold, and the star is about 5.4 to 9.8 billion years old. Many more planets are being discovered every year, and in early 2020, NASA discovered a planet the same size and same distance from its star as the Earth, about 13,000 light-years away. It was found using the microlensing technique and is very cold and likely has no life. It's known as an ice bowl planet and is too far away from its host star, which some scientists now say may not be a star at all but a brown dwarf. But even here in our own solar system, there's a possibility for life other than on Earth. The second largest moon to Saturn and the second largest natural satellite in the solar system is Titan. It's the only other known body in space other than planet Earth where there's clear evidence of stable bodies of liquid, and usually where there is liquid water, there could be life. Titan is a planet-like moon that is 50% larger than our Earth's moon and is 80% more massive. It has rain, lakes, and oceans, but it's not exactly what you're imagining here on Earth. It's far more bizarre. Titan also has valleys, mountains, ridges, mesas, and dunes, some of which are ice-covered deep lakes from vicious winter storms. Because it's far away from the sun, it only gets 1% of the sunlight Earth does. So how does it have an atmosphere with rain, ice, and liquid surfaces? Titan is much colder than the Earth, with surface temperatures around minus 290 degrees Fahrenheit, minus 179 degrees Celsius. Although it sounds like we're talking about water, Titan's atmosphere is 98% nitrogen and 2% methane, and the seasonal lakes are liquid ethane and methane. Even though its northern hemisphere is home to small liquid lakes, it's not really liquid at all. With these extremely cold temperatures, ethane and methane behave much like liquid water. However, Titan does have some warmth and may have what's called a home-baked atmosphere. What we mean by this is that organic molecules are likely cooked by the moon's warm core, and the decay of radioactive elements may warm the moon from within. With all this in mind, is it possible that Titan could harbor some form of exotic life forms? That might sound a little bit far-fetched, but scientists believe that Titan's atmosphere could be the perfect laboratory for studying the organic chemistry that preceded life, which provided the building blocks for life on Earth. Deposits of organic material have been found in some parts of Titan, showing proof that this giant moon could host biologically interesting compounds such as amino acids, which are the building blocks for all living things. Some scientists have regarded Titan as a deranged version of the Earth and at the same time say it resembles an infant Earth in many ways before life evolved and irrevocably changed our planet. Titan's ocean sits below a thick ice layer and is believed to have favorable conditions for life. Even though we're talking about life that exists in extremely harsh conditions, we already know of some life forms right here on Earth that can survive even in the vacuum of space, such as tardigrades, that can also survive minus 328 degrees Fahrenheit in temperatures as high as 300 degrees Fahrenheit. They can survive radiation, boiling liquids, and massive amounts of pressure of up to 6 times the pressure of the deepest part of the ocean without any protection. If this creature can exist in all these harsh conditions, there's no telling what kind of life could exist on Titan with its extreme environment. Some astrobiologists say that because there's a lack of liquid water on Titan's surface, there probably isn't any life there. But could life exist in Titan's methane seas? If life does indeed exist on the surface of Titan, scientists have agreed that it would be microbial, either very small in size or even single-celled organisms. But NASA thinks there's enough evidence for life and is planning to land a flying robot on the surface of the moon. We've already been to Titan before with the Cassini mission that almost everyone is familiar with. What most people don't know is that on January 14, 2005, Cassini jettisoned a small probe called Huygens, which made a spectacular film of its 2.5-hour descent into the surface. Huygens landed surrounded by round blocks of ice and saw dry shorelines reminiscent of Earth and many rivers of methane. The new mission is called Dragonfly and will be the first endeavor of its kind. It's a car-sized quadcopter equipped with instruments capable of identifying large organic molecules. The Dragonfly is supposed to launch in 2026 and arrive at Titan in the year 2034. When the craft arrives, it will land near Titan's equator among dunes composed of solid hydrocarbon snowflakes. It will be powered by heat from radioactive plutonium, much like NASA's Mars rover. But with its 8 rotors, it's going to be able to cover much more distance than any wheeled robot ever has. The Dragonfly drone will have to maneuver on its own, as light signals from Earth take 43 minutes to reach Titan, which makes Dragonfly much more complicated to operate than a standard drone. The drone will use a specially designed navigation system that will help it identify hazards and avoid them, and also be able to land autonomously. The AI that will be used on Dragonfly will be state-of-the-art. While in flight, the craft will sample the atmosphere and provide aerial images of the landscape. It will then fly to multiple locations hundreds of miles apart collecting data. But the ultimate destination is Cell Crater, which is a site of an ancient meteor impact where scientists say they found evidence of liquid water, organic molecules, and the energy that could fuel chemical reactions. This will be the 4th mission to be funded as part of NASA's New Frontiers program, which supports medium-sized planetary science projects that cost less than $1 billion, and Dragonfly will cost around $850 million at the time of launch. As for the future of Titan, it could become warmer in 5 billion years from now when the sun becomes a red giant and starts the helium-burning process. As our star expands, the outer layers will swallow Mercury, Venus, and eventually the Earth. But this changing sun may provide hope to other planets or moons such as Titan. Surface temperatures on Titan could rise to minus 94 degrees Fahrenheit, high enough for stable oceans of water-ammonia mixtures to exist on its surface. As the sun's ultraviolet output decreases, the haze in Titan's upper atmosphere will be depleted, lessening the anti-greenhouse effect on its surface and enabling the greenhouse effect created by atmospheric methane to play a far greater role. These conditions together could create an environment agreeable to exotic forms of life and will persist for several 100 million years. This was a sufficient time frame for simple life to evolve on Earth. In early 2020, NASA's Transiting Exoplanet Survey satellite, TESS, discovered an Earth-like planet named TOI 700d in its star's habitable zone, and is only one of the few that exist where conditions may be just right to allow the presence of liquid water on the surface. However, until more measurements are made, the exact conditions of this planet are unknown. This is where the James Webb Space Telescope will come into play. This telescope was supposed to launch on March 30th, 2021, and will provide improved infrared resolution and sensitivity far greater than the Hubble telescope. At a cost of $10 billion, it's one of the most advanced telescopes ever built. Its expensive mirrors covered in pure gold. The James Webb Space Telescope will be able to image even the most distant events and objects in the universe, such as the formation of the first galaxies. And it's believed that there will come a day when NASA will find a planet just like ours, flourishing with life. Earth is a pretty special and unique planet. So far, we haven't found anything like it in the entire universe. But that doesn't mean a super-Earth doesn't exist. In fact, they exist, and the chances are good for finding planets even better for life than our Earth. Now, the hunt is on to find liquid water, because where there is water, there might be life. A new telescope was set to launch on October 31st, 2021, packed with some amazing technology that might finally answer the big question: is there another Earth, or even a planet better than Earth, just waiting to be discovered? The human race is about to find out. Earth is the only planet we know of so far to have large bodies of liquid water on its surface, covering more than 70% of the planet. Other inner planets like Mars could have been wet early and evolved life before it became the harsh, barren world it is today. But finding liquid water on an exoplanet like the Earth, or even a super-Earth, is just the beginning of our search. Because if we discover liquid water on a planet's surface, the chances are good we're going to find life as well. This is because all living things need water to survive. Almost all the processes which make up life on Earth can be broken down into chemical reactions which require a liquid to break down substances. Observations from space and the ground have found abstract water to be one of the most abundant molecules in the universe. In fact, the Japanese spacecraft Hayabusa 2 recently brought back samples from an asteroid that have signatures of water and organic material. The most amazing thing found was that the asteroid didn't pick it up from somewhere, but is a source. This means there could be many super-Earths with water just waiting to be discovered. If we're searching for an exoplanet that's going to have liquid water, it needs to meet some criteria. For one, this planet needs to be a certain distance from its host star. If it's too far away, any water on the planet will freeze, unable to support life. And if a planet is too close to a star, everything would burn away, including oceans and any atmosphere. The interesting thing is that scientists from NASA have recently said exoplanets with oceans may be common in our Milky Way galaxy. But with the current technology we have, there isn't a way to detect liquid water on the surface of an exoplanet, at least not yet. However, there's a way to look at a planet's atmosphere and detect water vapor. And if there's water vapor in the air, chances are good it's evaporating from the ground or coming from huge oceans. In 2015, the Kepler Space Telescope found an exoplanet the size of 8 Earth masses called K218b that orbits a red dwarf star and is located 124 light-years from Earth. Its gravity is a bit stronger than Earth's, but it's a pressure on this planet that's intense. In 2017, data from the Spitzer Space Telescope confirmed this super-Earth to be orbiting its host star in the habitable zone and taking just 33 days to complete an orbit around its star. K218b is the best candidate as a habitable planet that NASA has ever found. This is because in 2019, 2 independent research studies, combining data from the Kepler, Spitzer, and Hubble space telescopes, found a surprising amount of water vapor in the planet's atmosphere. Researchers took that data and examined the spectra of starlight passing through the planet's atmosphere during transits or when the planet passed in front of its host star. K218b has a hydrogen-helium atmosphere with a high concentration of water, ranging between 20% and 50%. It's even suggested that this planet has rain clouds. K218b also gets the same amount of radiation from its star as Earth does, as the Earth does from the Sun. So if we could travel faster than light speed, could we go live on K218b? Some researchers say that the planet has a large and extremely thick atmosphere that creates high-pressure conditions that might prevent life as we know it from existing, but there's also no surface for us to land on. That's because most of the planet is surrounded by a huge gas envelope. There's probably some sort of rocky core that's surrounded by a massive hydrogen gas envelope that has some water vapor in it. That means landing on this planet would be nearly impossible, and since the gas is so thick with an incredibly high pressure, any Earth-created spacecraft sent there would be destroyed, crushed and squeezed from the millions of bars of pressure. That doesn't sound like any place we can inhabit, but don't give up hope on us finding a super-Earth just yet. First discovered in 1999, TRAPPIST-1 is an ultra-cool red dwarf star with a radius slightly larger than Jupiter and lies about 39.46 light-years away from Earth. On February 22, 2017, NASA announced the discovery of 7 Earth-sized rocky worlds orbiting the single star, and every one of these planets has a potential for having water on the surface. Just a year later, in February 2018, a closer study found that these 7 planets could have more water than the oceans of Earth, and 3 of these planets are just the right distance from the star to be warm enough for liquid water. The Hubble Space Telescope was used to find that TRAPPIST-1b and C unlikely have hydrogen-dominated atmospheres like gas giants. This makes a strong case that the 2 planets are rocky and possibly hold water. But both TRAPPIST-1b and C have extremely thick and hot atmospheres, somewhat like the planet Venus. But unlike Venus, these exoplanets are too hot to allow the formation of sulfuric acid clouds. It's possible both planets could be so hot their surfaces are covered in molten lava. TRAPPIST-1d is the least massive planet in the system and likely has a compact, hydrogen-poor atmosphere that is similar to Venus, Earth, and Mars. It has half the gravity of our planet, and it gets about 4.3% more sunlight from its star than Earth does, and it lies on the inner edge of the habitable zone. This planet could have oceans or layers of ice. However, a new study shows that this planet could be more like Venus with an uninhabitable atmosphere. TRAPPIST-1e is an exoplanet which orbits around the habitable zone and is similar to Earth's mass, radius, gravity, and temperature. Astronomers say it has a compact atmosphere, and this one has the greatest chance of being an ocean planet like Earth. This planet really does have the chance of being potentially habitable for life as we know it. TRAPPIST-1f is likely a rocky world like ours, but is under a massive water-steam gaseous envelope at very high pressure and temperature. This planet could very well have a thick ocean of liquid water covered by an atmosphere rich in abiotic oxygen. However, this exoplanet may likely be no more habitable than any other gas or ice giant with water clouds in its atmosphere. TRAPPIST-1g could also have a thick global water ocean covered by an atmosphere containing hundreds of bars of abiotic oxygen, and TRAPPIST-1h is a cold world with temperatures around minus 155 degrees Fahrenheit, similar to Earth's South Pole, and is likely covered in ice. However, scientists say it could possibly hold liquid water. The TRAPPIST-1 planets are all likely tidally locked, meaning that any of these planets could have a zone that's warm enough for life and doesn't get bombarded from radiation from their host star. Even though right now there are a lot of unanswered questions about the TRAPPIST-1 system, it is the most thoroughly known planetary system apart from our own. But soon we might find out that one of these super-Earth exoplanets does have liquid water and life. The James Webb Telescope, a triumph of space science that might just be the most famous unmanned spacecraft since Sputnik, is set to be launched on Halloween, October 31st, 2021, and the planets in the TRAPPIST-1 system are the first world it will observe. Its main goal is making the first detailed near-infrared study of the atmosphere of a planet orbiting the habitable zone. To find signs of an atmosphere, astronomers will use the James Webb Space Telescope Special Near-Infrared Spectrograph, also known as a spectrometer, which disperses light from an object such as a star into a spectrum. Analyzing the spectrum of an object can tell us about its physical properties, things like the temperature, mass, and the chemical composition of the object. Atoms and molecules in the object imprint lines on its spectrum that uniquely fingerprint each chemical element present and can even tell us about the physical conditions in the object itself. The exciting thing about the JWST is that it will be able to see oxygen in alien atmospheres of planets orbiting their stars. There are at least 4,000 exoplanets that have been found so far, and many of these are orbiting in the habitable zone. The presence of life forms such as algae, plants, and cyanobacteria here on Earth has filled our atmosphere with a vast amount of oxygen, about 20%, which is far more than our planet would have if there were no life on it. Studying the Earth helps us understand what we need to be looking for if we're going to find a super-Earth out there. And using the James Webb Space Telescope plus a new technique developed at the University of California, Riverside, researchers hope to see signs of oxygen molecules colliding with each other in the atmospheres of distant worlds. When oxygen molecules collide, they block a percentage of the infrared light that will be normally seen by telescopes. The James Webb Telescope will be able to send back data that researchers can use to determine what the chemical makeup of an alien atmosphere is. The JWST will also look at water worlds. Some of these can come too close to their star or build up heat from a runaway greenhouse effect, such as what happened to Venus, and they can lose their oceans to space. When this happens, radiation breaks apart the water into hydrogen and oxygen molecules. Hydrogen is the lightest, so it will quickly float out into space, leaving behind oxygen. Oxygen is one of the most exciting things to detect in a planet's atmosphere because of its links to life, but we don't know if life is the only thing that produces oxygen in an atmosphere. But the advanced technology and the technique will allow us to find oxygen in planets both living or dead. The chances of mankind finding life out there look good. We just haven't had the technology to detect it until now. Are you excited for what the James Webb Space Telescope is going to find? And do you think we'll find life out there? Tell us what you think, and don't forget to stay tuned here, because things are changing quickly, and it might be any day now that we finally find life in a possible super-Earth. Scientists have been finding exoplanets that could be potentially habitable for some time now. There are hundreds of millions of them out there and more found every day. There isn't a planet like ours anywhere in the universe that we know of, but now scientists say they have found exoplanets that could be more habitable than the Earth. But do they really exist? An exoplanet, or extrasolar planet, is any world that orbits a star outside of our solar system. Exoplanets can range in size from gas giants larger than Jupiter to small rocky planets like Mars and Earth. Most of the planets that have been discovered lie in a small region of the Milky Way galaxy, and we know from observations made by NASA's Kepler Space Telescope mission that there are more planets than there are stars. The first exoplanets were discovered in the 1990s, and since then we've discovered thousands more using several different methods. But it's not an easy task finding them. There could be at least 300 million potentially habitable exoplanets in our Milky Way galaxy alone. The U.S. Space Agency's Kepler Space Telescope spent 9 years on a planet hunting mission and identified thousands of these exoplanets in our galaxy before it ran out of fuel in 2018. After going through all the data Kepler collected, those 300 million rocky planets could be capable of supporting liquid water on their surface. This is just a rough estimate because there are between 100 and 400 billion stars in the Milky Way, and every one of those stars probably hosts at least one planet. That means there are likely trillions of planets out there. You may think it's as simple as using a telescope to find them, but it's rare to see an exoplanet the way you would see Saturn from Earth. This is called direct imaging, and very few exoplanets have been found this way. Most exoplanets are found by using the transit method, which measures the dimming of a star as a planet passes in front of it. We can also find exoplanets by measuring the star's light spectrum for signs of a planet pulling on the star, causing the light to shift, or finding them using gravitational lensing. Using all these together is allowing us to find more exoplanets every day in the vast universe. If we're going to look for exoplanets that could support life as we know it, the first place to look is at planets that orbit their host stars in the habitable zone, or what some scientists call the Goldilocks zone. This is the area around a star where it's not too hot or too cold for liquid water to exist. But the planet also has to be the right size, and the type of star that the exoplanet orbits has to be a certain type, and it should be stable. Our own sun, a yellow dwarf, has had a stable existence for over 4.5 billion years. But this is not always the case for different stars in other systems. But we'll talk more about different types of stars in a moment. First detected by the Harps telescope in 2016, Proxima b is the closest alien exoplanet to our solar system at 4.2 light-years from Earth. It lies in the habitable zone of its red dwarf star, Proxima Centauri, and was thought to be a minimum 1.3 Earth masses. But a new telescope named Espresso recently discovered Proxima b to be only 17% more massive than our planet, making it more Earth-like than it had previously been thought and a candidate for life because it's the right distance from its host star to have liquid water. Scientists believe that the planet could be habitable, and future generations of superpower spacecraft could travel to the planet in search for life. But that same year, a massive solar flare had erupted from the red dwarf star Proxima Centauri that was 1,000 times brighter than the star itself. It hit Proxima b with 4,000 times more ultraviolet radiation than the Earth would get from a solar flare from our Sun, and researchers believe that this could have wiped out all traces of life on the planet. But Proxima b is not the only candidate as a habitable planet. Scientists now say they discovered 24 superhabitable planets or exomoons that could be better suited for the emergence and evolution of life. The concept superhabitable came from two researchers in 2014, Renee Heller and John Armstrong, who stated it takes much more for an exoplanet to be habitable than just being in the habitable zone. Things that would make a planet more suitable for life as we know it mean they could be older, larger, warmer, wetter, could have higher levels of oxygen, and a longer-living star. Heller and Armstrong have proposed that the required size of a super-Earth would have to be 2 Earth masses because radioactive decay in the planet's interior would last longer to provide heat, and the stronger gravity would hold on to the atmosphere longer. These 24 superhabitable exoplanets were chosen because they have a star of the right size, lifespan, and lie in the habitable zone. Many of these orbit around G-dwarf stars similar to our Sun, but researchers also look for exoplanets orbiting around K-stars, orange dwarf stars that are cooler, less massive, less luminous, and there are 50% more orange dwarfs than yellow dwarfs in the Milky Way. While these sun-like stars might not sound ideal for life, they have a big advantage. Their lifetimes are anywhere from 17 billion to 70 billion years, compared to the 10 billion-year lifespan of our Sun. If life started on a planet orbiting a K-star, life would have had much more time to evolve than life on Earth has so far. Considering it took complex life 3.5 billion years to evolve on Earth and 4 billion years for advanced life such as humans, a larger-sized exoplanet could mean more space for landmass and habitat. These superhabitable worlds would also have a higher gravity and a thicker atmosphere, allowing beneficial organisms to travel through the air, spreading life. Planetary scientists say the sweet spot age of a superhabitable exoplanet is about 5 to 8 billion years. Of course, a more superhabitable planet would need water for life as we know it to survive, planets with more moisture. And an average surface temperature 8 degrees Fahrenheit warmer than Earth could make them more habitable, since we understand there is more diversity of life in warmer and wetter climates. Some of these more habitable planets could resemble the Earth in the early Carboniferous period about 359 million years ago, when the planet had the climate of a tropical rainforest. Gliese 667cc is the next closest superhabitable exoplanet, which orbits a red dwarf star in the Gliese 667 triple star system. Yes, 3 stars. If you were standing on Gliese 667cc, this is likely what you would see in the day sky. Gliese 667cc lies 23.62 light-years from Earth, and is a minimum of 3.7 Earth masses. Another possible superhabitable world could be Kepler 452b. It's sometimes called Earth 2.0 and orbits a G-type star which is very similar to our Sun, except that it's 1.5 billion years older and slightly bigger. Some authors speculate that there could have been an ancient civilization on the exoplanet or the moon orbiting it, but it's possible that we're now seeing a glimpse of the future fate of Earth because the star it orbits used up its fuel and has expanded into a red giant. But there are other things that we should be looking for. So far, there's been no way to detect oxygen in an exoplanet's atmosphere, but soon things will change. On October 31st, 2021, the James Webb Space Telescope is scheduled to be launched into space on an Ariane 5 rocket. The technology on the telescope is unlike anything ever designed. It's the successor to the Hubble Space Telescope and will be a powerful new tool in the search and study of exoplanets that could support life. The James Webb Telescope will move out 940,000 miles away from the Earth, well beyond the orbit of the Moon, where it will set up shop and orbit the Sun. It will be the largest observatory ever sent into orbit and will use special cutting-edge optical science and engineering to peer into the unknown. Researchers say they developed a new technique that will allow the James Webb Telescope to detect a unique signal produced when oxygen molecules collide. If this signal was found in an atmosphere of an exoplanet, that would mean it would have oxygen and perhaps life as we know it present on the planet's surface. Despite all this amazing technology, if a planet orbiting a red dwarf has an atmosphere similar to Earth's, it will need to be within 16 light-years for the Webb telescope to detect the oxygen signal. After its 2021 launch, the James Webb Telescope will study the history of our universe, including distant exoplanets, other galaxies, and the first luminous glow of the Big Bang and the evolution of our solar system. But we may need something more powerful to look farther out into space. The Nancy Grace Roman Telescope will be launched sometime in the later 2020s and will have 100 times the viewing field of the Hubble Space Telescope. It'll probe the depths of dark matter and dark energy, the mysterious and mostly unknown phenomena that makes up most of the universe. The most exciting thing is it'll be able to make direct images of exoplanets, something not possible from planet Earth. But the main goal of its mission is to peer into the interior of the Milky Way galaxy, where it would possibly find thousands more exoplanets through gravitational microlensing. But if we do find life out there, we must remember the universe is fascinating and very diverse, and the best place for life, such as super-habitable worlds, might not be like Earth in any way we traditionally imagine. We're entering a very exciting time in human technology, and with a number of habitable worlds out there, it's likely that we'll finally discover life on a distant world. The Kepler telescope was built for one purpose, to look at a certain patch in the Milky Way in search of exoplanets. The exoplanet hunter observed over hundreds of thousands of stars and discovered thousands of exoplanets during its lifetime. Liftoff of the Delta II launch in 2009 as part of NASA's Discovery program. Kepler's job was to constantly scan a fixed patch of sky within our Milky Way galaxy to find planetary systems. At the time of the launch, it had the largest primary mirror ever sent into space, and it also had a 96-megapixel camera to process the light. Astronomers were interested in finding out just how many stars or planets orbiting around them and how many of these extrasolar planets, or exoplanets, have conditions that are suitable for life to develop. In its 9 years in space, Kepler observed 530,536 stars and confirmed the existence of 2,662 new exoplanets. These exoplanets are unlike anything we've ever seen in our solar system before. Most of them are significantly bigger than Earth and orbiting so close to their stars that they complete one revolution every several days. And there are some very strange worlds. Some have star-facing sides with temperatures that can melt iron and have entire hemispheres covered with oceans of liquid molten rock. Other exoplanets the size of Jupiter orbit not one but two stars. If you're standing on the surface of one of these planets, you'll be able to see a binary sunset. But Kepler's legacy is that it successfully found Earth-sized worlds orbiting at a safe distance from their host stars inside what's known as a habitable zone or Goldilocks zone. This is where the temperatures are warm enough for water to condense on their surfaces, but not so cold that it will just freeze up entirely. Although being in this zone doesn't guarantee the existence of life, the presence of water is significant and the foundation of life as we know it. One such exoplanet discovered by Kepler that has recently generated excitement among researchers is called K218b. In September 2019, two scientific teams independently announced that they found signs of liquid water in the planet's atmosphere. Situated 124 light-years away from Earth, K218b is about 8 times the mass of Earth and 3 times as big. It orbits a main-sequence red dwarf star called K218. A red dwarf star is the smallest, coolest star, and by far the most common type of star in the Milky Way. According to Kepler's data, astronomers estimate that 6% of red dwarf stars have an Earth-sized planet in the Goldilocks zone, at least in our neighborhood. To find water on the surface of one such planet is a landmark discovery in the search for potentially habitable alien worlds. K218b is also the first planet with water out of all of the exoplanets discovered by Kepler in the habitable zone of stars. Kepler first discovered the planet in 2015, and since then its composition has been studied using other telescopes like the Spitzer and Hubble Space Telescope. Kepler mainly used what's known as the transit method for exoplanet hunting. It essentially means that if a planet passes in front of a star, the light from the star dims slightly, and that's how we can tell that there's a planet there. The level of dimming and how long it lasts gives us important information about the size and orbit of the planet. However, detecting the transit of an extrasolar planet is very challenging. For example, the diameter of Earth is only 1/109 of that of the Sun, so for an outside observer of the solar system, the passage of Earth would dim the output of the Sun by only 0.008%. Kepler's cameras had to be sensitive enough to detect this minor change in the luminosity. Using the same method, way back in 2014, Kepler first found potentially habitable exoplanet. Kepler 186f ignited the imaginations of space nerds everywhere when NASA announced its discovery. Now, a new study indicates the exoplanet 500 light-years away may also have seasons and a climate similar to our own. New research out of Georgia Tech University has analyzed the planet's spin and axial tilt and found that its tilt is stable like Earth's, which makes it likely that Kepler 186f also has regular seasons and a stable climate. Similar research on the massive Kepler database is going on in research universities all across the world. In fact, in recent years, previous Kepler findings that were rejected as potential Earth-sized exoplanets due to algorithmic error are getting rediscovered. These false positives are now slowly being reanalyzed in conjunction with data from other telescopes. One such planet is Kepler 1649c. In mid-2020, while combing through old Kepler data and matching it against new data from the Transiting Exoplanet Survey Satellite, or TESS, astronomers confirmed the existence of another exoplanet with very favorable conditions for life. Kepler 1649c, located 300 light-years from Earth, is very similar to Earth in size and estimated temperature. This newly revealed world is only 1.06 times larger than our own planet. Also, the amount of starlight it receives from its host star, which is also a red dwarf, is 75% of the amount of light Earth receives from our Sun, meaning the exoplanet's temperature may be similar. To our planets as well, Kepler 1649c provides yet another example of an Earth-sized planet in the habitable zone of a red dwarf star. But before we get ahead of ourselves, it's important to note that out of the 2,662 exoplanets identified by Kepler, only 16 of them lie inside the Goldilocks zone. And out of these 16, some of these planets are tidally locked with their parent stars, meaning that only one hemisphere of the planet faces a star, and this is not ideal for life. Others are more like a smaller version of Neptune than a larger version of Earth, and planets similar to Neptune are expected to have a significant envelope of hydrogen surrounding any layer of water on the surface, with a planetary core of rock and iron. If the hydrogen envelope is too thick, the temperature and pressure of the water layer beneath would be far too great to support life. On top of all this, despite being cooler, red dwarf stars tend to be more active than sun-like stars, thus the planets may be exposed to higher quantities of damaging ultraviolet radiation than what we're used to here on Earth. Because of this, surface temperatures can range between -100 and 116 degrees Fahrenheit or -73 to 47 degrees Celsius. That means the surface could, on average, be colder than Antarctica or hotter than Earth's most blistering deserts. Unfortunately, we just don't have the technological know-how to study the composition and atmospheres of these alien worlds and comprehensively answer all these questions yet. But don't despair. Based on the statistical analysis of all the Kepler observations, astronomers now estimate that 1 in 5 stars like the Sun have planets about the size of Earth and a surface temperature conducive to life. Given that about 20% of stars are sun-like in our galaxy, that amounts to several billions of potential habitable Earth-like planets just in our Milky Way alone. Kepler not only focused its efforts in finding potentially habitable planets. In fact, the bulk of its discoveries were strange worlds not suitable for life but fascinating nonetheless, like the gas giants, planets composed mostly of gases such as hydrogen and helium with a relatively small rocky core, also known as hot Jupiters. These planets orbit extremely close to their parent stars and are abundant in Kepler's data. One such fascinating example of a gas giant is KOI-5ab. Astronomers first flagged KOI-5ab as a potential planet way back in 2009. At the time, this elusive alien world was only the second planet ever found by Kepler. It slipped through the cracks a decade ago, firstly due to the enormous amount of data that Kepler generated, and secondly because astronomers noticed that the main KOI-5a star had another companion star, making analysis very difficult for them. Indeed, the KOI-5 system was even more complicated than researchers realized at the time. By 2014, scientists had determined that the KOI-5 system actually harbors 3 stars, and it still wasn't clear if the planet KOI-5ab actually existed, or if the 2009 signal was generated by one of the companion stars. But thanks to additional data from the TESS satellite, scientists were able to confirm the existence of KOI-5ab. Planetary bodies on stable orbits in a multi-star system is quite a rare find, and the discovery of KOI 5AB is expected to add a lot to our understanding of planetary formation. Other exoplanet types identified by Kepler include super-Earths. They are more massive than Earth, yet lighter than ice giants like Neptune and Uranus, and can be made of gas, rock, or a combination of both. Lava planets, super-dense, larger-than-Earth worlds in close, hot orbits around their parent stars, some of them known as Thonane planets, are likely the remnant cores of evaporated hot Jupiters. And finally, Trojan planets. Planets of various sizes found in strange locations, and sometimes even as companions to larger planets, though none have been certainly identified yet. Kepler was finally retired on the 30th of October, 2018, as it ran out of fuel. The telescope was deactivated with a good night command sent from Mission Control the next month. Coincidentally, Kepler's retirement fell on the 338th anniversary of Johann Kepler's death, after whom it's named. Although not operational anymore, these incredible discoveries predict a near future in which astronomers will use new and advanced telescopes on the ground and in space to more deeply understand Kepler's numerous finds. One such telescope is already slated to go up into space in 2021. The James Webb Telescope will take a much closer look at some of these Kepler objects of interest and hopefully will bring us closer to answering the question, are we alone in the universe? What do you think? Will astronomers find many more strange worlds buried inside Kepler's data? Let us know in the comments section below. Thanks for watching Dark Core.